My name is Azhar, and we're going to talk about virtualizing a central office. What are some of the requirements, and what are some of the gaps? I also had something in the title there, aka CORD, but I was told later on that CORD is actually a registered trademark of the OnLab, and they are actually using CORD as a means of promoting the ONOS controller and the XOS as part of that overall architecture. So I decided not to use that word CORD in the presentation, but you get the lean in terms of where I'm going, and particularly why here and why Open Daylight, because we believe that Open Daylight can solve a bunch of problems. So virtualizing a central office, that's a picture from one of the books that talks about sectional view of a telephone building. It's a typical American central office organized by departments, so nicely done, right? Now, which one does your central office look like? That one or that one on the right-hand side, but that was a joke. Let's talk about central office services. What are some of the services? What are some of the requirements to build a virtualized central office? What's the architecture look like? What are some use cases? And why should we look at this differently than what's been done so far? Then I have a proposal in front of the team, in terms of the broader team, and we'll just wrap it up with a summary. In order to build a central office, the goal is to define a cloud-native approach to virtualizing a central office leveraging open source technologies. Obviously, you want to be able to build end-to-end services. You want a choice of technologies and capabilities with orchestration and automation at scale. Now, if we look at the central office components, what are some of the services that reside today inside a central office? Many subscriber management services, both for residential and mobile. Subscriber gateway functions, authentication authorization functions, event and subscriber information logging, correlation. The physical termination capabilities, whether it's optical termination, whether it's DSL termination, but there's some termination of the wires and the lines itself. The various different service functions that reside there. Portals, NAT firewall routing that allow you to actually service chain that information together. QoS management, quota management, billing capabilities, caching, local information servers for content, mail and file stores. And then if you talk about putting mobile gateways in there, then there are a whole bunch of mobile services that are associated with it that reside in a typical central office. Now, central office vary by different sizes. Some of these, not all of these functions may be in all central offices. Some of these functions may be in some central offices. Other functions may be in other central offices. But in general, this is kind of the broad swath of things that you see inside a central office. Then the question becomes, okay, can I take this set of services, model it in a different way, and come up with a virtualized model for a central office? Can that be done? Now, if we look at NFV use cases, interestingly, these are the top 4 use cases: business virtual CPE, service chaining, virtual IMS, virtual CDN. Interestingly, all of those use cases are central office functions. So it's quite important that we actually not just look at what does it take to just virtualize the termination capabilities of a central office, but we actually look at what are the services that reside inside a central office and how do we virtualize them and take a completely different view than what people are thinking about and how we do that. Now, we all know about this whole leaf spine architecture of a typical data center. And most of the traffic here flows north-south. By actually moving those WAN interfaces to the fabric itself, you can create a bigger east-west traffic flow. Now, the reason why I bring this particular architecture up is what you can do is actually take a snapshot of this architecture in different sizes and put them inside a central office, where instead of those WAN termination ports that you see over here, you could actually then now begin to terminate those OLTs and the DSL termination capabilities, creating better bandwidth, better management, better optimization. Now, everybody must be asking, where does the ODL come into picture? Well, ODL comes into picture as soon as you start to manage that overlay, underlay networks and fabric, right? Well, the question is really, can you manage fabric? We'll come to that in one of the slides later. But as I was talking about earlier, we have a whole bunch of different sizes central offices come in. You can take the mini pod model, you can take the small pod model, you can take the a micropod model, And you can decide to virtualize a set of services first. It's not necessary that you take that entire gambit of functions that you see that I showed you in slide 2 or 3 and start to virtualize all of them at the same time. So if you take a look at, for example, a residential service model, then you can actually just say, okay, what are my functions associated with a residential service? Start to virtualize them, deploy that at the central office in some small pod type of capability that allows you to then effectively scale and manage. So what do we need really for a software-defined central office? We need service definitions, appropriate service definitions, we need service provisioning, and then we need subscriber service chain management and automation for those capabilities. Again, I'm stressing on these points because I'm taking a completely service-driven view of what it takes to virtualize. And then later on when I talk about the architecture and the use cases, you will see how I'm going to map the service-driven view into the architecture and the use cases and drive that conversation in a completely different context than what was previously discussed in terms of using AKA the cord models. So if you take the residential services model, here's a very high-level view of a residential services model. What you have on the left-hand side here is your residence with a demarc point and probably an optical network termination unit, right? So with that ONT across a GPON network, you have a optical line termination capability. There's been some good amount of work done by PMC Sierra and AT&T and a bunch of others in terms of trying to build a virtualized OLT. Now that virtualized OLT can plug directly, for example, into the fabric, into that data center fabric, providing you that horizontal scale that we showed in a few slides back. And then at the back end, you can then provide a set of services using those virtual machines or virtual network functions, orchestrate them. So those then the question of building the forwarding graphs using ODL controller, the question of creating that overlay using the ODL controller, so the question of how do you manage these set of services based on a per subscriber basis can be done at the back end inside that particular central office right over here with various different capabilities. Take again the mobile context. In the mobile context too, you have a bunch of gateways. Whether they are SGWs, PGWs, or EPDGs, that's it. Some of these gateways sit closer to the user at the central office. Some of these gateways may sit far away from the user. But again, they are part of that particular data path and data termination path. So hence, you can actually place them, virtualize them, place them in that particular central office so that it allows you to efficiently offload that particular traffic. Now, looking at these two high-level use cases, the residential and the mobile, how can we do it? What does it take to actually go virtualize? Let's put a framework in place together. So what are the components that we need from an overall framework perspective? We need an orchestrator. We need some VNF specifications, and we need some configuration management capabilities and a catalog. We also need some VNF managers. We need the infrastructure, which is OpenStack and or containers that's managed through either OpenStack or Kubernetes. And we need the VNFs themselves to create that particular end service, the NFVI, as well as the backend OSS, BSS billing systems. Now, you can specify the VNS descriptors using Tosca with VNFD and NSD. Use a tool like ManageIQ, for example. There was an OPNFV demo that Red Hat did about 2 months back, Pazzi? About 2 months back to actually show you how that can be done. Use a tool like ManageIQ and then actually go build that service chain function and orchestrate the entire environment and actually show a particular service. So if you look at that particular framework and then look at the requirements were, remember we said residential services, business services, and mobile services. And in order to deliver those functions from a central office, we need to look at the architectural requirements within that particular framework we just described a moment ago. What are those architectural requirements? We need the ability to manage the network overlay. We need the ability to manage the fabric. We need the ability to manage that entire service chain capability. We need the ability to manage the containers and virtual machines. And in fact, there was a presentation earlier on in this room. I don't know if you happened to witness that. It was by Ericsson. And they talked about ODL and Kubernetes integration. I thought that was just perfect in order to fit this particular service scenario. VNF lifecycle management and VM lifecycle management, as well as the ability to do fault and event correlation functions from a service point of view, towards the end-to-end. Now let's just go dig, because remember, we identified these two cases. Let's just take the one residential use case and dig a little bit more into the virtual CPE model, which is what is potentially used for that residential or business services use case. Now, the reason why we want to do that is, again, we need the ability to identify those piecemeal components so that we can create the VNF forwarding graph using ODL. We can see what those gaps are, where do we need to fill in order to build the overall reference architecture. I do want you to think a little bit differently when you talk about physical CPE versus virtual CPE. Virtual CPE is not about taking a device and putting some wrappers around it running on a virtual machine. I want you to think of virtual CPE as a disaggregated set of services that are put together loosely coupled to deliver a capability that are tied together either via service chain and orchestrated using various different orchestrators or controllers. And of course, in this particular case, ODL. So the physical CPE becomes pretty rigid in that sense. That becomes pretty flexible. So virtualizing a bundled physical CPE is not equal to virtual CPE, but it's really a disaggregated set of functions that are tied together. Now, those, again, we did talk about both the residential and business. Let's take the virtual CPE for residential and business and see what happens here. In the residential case, we saw that this was just a NID that was residing here. In the enterprise case, it could be a NID, or it could be another device that sits there with some network functions that are there. So now you need the ability to build those service chains with network functions that are sitting here, as well as network functions that are sitting inside this particular data center. Again, that data center is nothing but your central office, your software-defined central office. So what are some, let's double-click a little bit more on that previous slide and look at those capabilities. If we see this particular LTNID, now here you can have a termination capability, whether that's ONT, or whether it's DSL termination, whatever. And then at the back end, you have some subscriber termination with virtualized BNG or virtualized set of services that are there at the back end, with a number of VNFs that are chained together as part of the service chain. You saw some interesting presentations at this conference on how service chaining can be done using ODL. Well, you can potentially use ODL directly to build that particular service chain that's required on a per sub basis or on a per site basis. Now, in this particular case, where there are some network functions that are sitting out on a CPE with the quote-unquote thick CPE model for an enterprise use case, then you need the ability to manage this service chain right here with this service chain right here on a per customer basis. Now, is that possible today in the ODL service chain capability? Obviously, that's one of those things that we need to work on as a gap or as a project in terms of what it takes to do it. Now let's put those different sets of components we saw together. And this is where I'm going to spend a little bit of time just walking you through the various different components. So we did say that in terms of the overall framework, you have an orchestrator like ManageIQ, for example, that can push a set of job templates for automation with Ansible that allows you to go configure these VNFs. Now, this is not necessarily, I'm just giving Ansible and ManageIQ and those things as examples because those happen to be from Red Hat, but you can take open source components here and actually place them in this particular framework to actually achieve the goal that you want to. Now, we did see an interesting presentation on the Open Daylight and Kubernetes integration, and that's where this particular link, particularly with Kubernetes and Open Daylight, comes into picture. And they're proposing something for the next release, for Boron release, in terms of how you can use a Courier and Neutron API to accomplish this, or using the CNI directly in terms of the interface to accomplish it between Open Daylight and Kubernetes. So that's one of the things that we still have to do in order to achieve this. But again, using Open Daylight, the components within Open Daylight Controller are available for you to be able to configure the overlay, to manage the service chain, to create those tenant networks. And you can use a VNFM like Tacker to be able to manage those VMs. You provide those descriptions through Tosca, NFD, and NSD, VNFD and NSD. So what we find through this particular framework is most of these components, in order to build that virtualized infrastructure using ODL as your primary controller, are available. There are some gaps, however. The gaps exist in areas that are related to integration of, for example, Kubernetes with Open Daylight. There are some gaps that are associated with creating that entire data center fabric, that big picture that we put up, and do fabric management and control. Now, are there capabilities today with ODL that allow you to maybe do that? Potentially there are. This is work in progress. And so that brings me to my next slide is a proposal or call to action. In order to be able to build a virtualized central office with ODL, there are a whole bunch of components that are there for the residential and mobile. Those are the two use cases we're going to focus right now on, right? You can use the ODL controller to configure the overlay, to configure the service chains, to configure the tenants. We do need to work on the fabric management stuff. We do need to work on the Kubernetes and ODL integration capability. And why? Then the question becomes, okay, so ONOS already has this capability. Why are you trying to reinvent the wheel yet again? Well, simply, ODL has the largest community out there. It's the most widely accepted controller at the moment. A number of service providers you talk to are interested in minimizing the number of controllers they have in their network. And most of the components exist in ODL. It's a small set of changes that you can add to ODL in order to be able to achieve this.
The answer to that question is why not?
There you go. I think that's a better answer, but I was trying to be a little bit more defensive. Okay, so if we take those components and try to map it out in terms of various different capabilities with OpenStack, Kubernetes, and ODL, but that's kind of the mapping. And the biggest gap that really shows up is in this, fabric control and management, and the other one that I did not write is in the Kubernetes ODL integration. And the good part is the Kubernetes ODL integration work, Ericsson is already trying to push, and Red Hat's part of that group in terms of that's contributing to it. And then there is already a way to do it today using Courier and Neutron. So that's work in progress. That will be there. Then the only other thing that becomes in terms of work to be proposed or to make it happen is the fabric management stuff. And once we get that fabric management, potentially you can do entire virtualization of the central office through complete set of open source tools. So yes, sir.
Question. Well, I agree the term core today is being used as a marketing term for own lab. I think as you rightly pointed out, the solution isn't unique to almost the controller for the controller fabric, as well as the VPN stuff. Any controller that can do those things can do it. And there are some commonality in terms of the rest of the pieces are controller independent, essentially. Have you begun discussions with ON Lab about is there some room for coordination?
Absolutely.
Collaboration?
So no, that's a very good question. In fact, tomorrow at 1:30, I'm hosting a small workshop right here to actually drive that conversation and that discussion. There are a number of service providers who are interested in this conversation. And there are, Linux Foundation's been involved in this, given that now ONOS Controller is also part of Linux Foundation. I'm working with Phil, Casey, and the team as part of the Linux Foundation to see what components, if any, can be leveraged, or can we drive a commonality, or do we need to is it a matter of adding another project to ODL and just showing that particular capability? I don't know the answer to that particular question. I think it needs to be a community-driven answer. I'm happy. Let me just step back for a moment. How did this get started? What happened was about 4 months ago, we were having a discussion with some of the service providers. And they said, hey, I have this proliferation of controllers. I have an Open Contrail, I have ONOS, I have ODL, I have somebody else, Cisco NSO, and I don't know how many others. I'd like to see how much of commonality can I drive across these controllers and minimize. And obviously, if I were to bet the farm on something, it would be ODL going forward. So we said, okay, so what do you need to make this happen, and what are the type of services you're trying to drive. Then very quickly the conversation went down to, oh, go look at what this OnLab has done. So we started doing that. But at that time, OnLab hadn't open sourced their capability, and ONOS controller wasn't part of Linux Foundation when we started this activity. But then subsequently things changed. OnLab open sourced it, and now Linux Foundation has two of them at their hands. So it's work in progress. It's a conversation that's still going on. Hopefully we don't have to reinvent the wheel and we can leverage. But again, my interest was to originally see what's really the delta from an ODL perspective, because ODL has such wide adoption at the moment. Welcome. So just then wrapping it up with the summary in terms of what we want to do and what we really are trying to drive here. Certainly NFV allows us to virtualize those set of services, and if you take a services view, you'll take a very different view of the picture. You're not talking about now, line terminations and those type of capabilities, but you're really trying to talk about how do I take this set of services, orchestrate them, use ODL as a controller for that, use other open source orchestrators that are available to build that end-to-end service. ODL is certainly a viable controller, and it fills most of the gaps, barring a few holes here and there. And hopefully we can create some projects here to actually fill those holes. Certainly it has the largest community. Having fewer controllers eliminates the need, from an operations perspective, from a multiple different contexts, fewer interfaces to manage, easier to integrate, simpler operations, et cetera. And hopefully those gaps can be addressed with this particular project. So if you're interested, join us. As I said, there is a workshop we'll be holding in room 403 tomorrow at, I believe, 1:30. So, any questions? Yep.
What is the plan of ECOM?
eComp is an AT&T driven architecture that's much more than ODL. Okay, and eComp, I don't want to go into the details of the eComp architecture itself, but I believe AT&T themselves use ODL as one of the controllers as part of that particular architecture. If anybody from AT&T can maybe speak up, or okay. And AT&T has decided to open source eComp, and I think there's one other provider, Orange, trying to look at eComp. eComp is a much bigger picture than what I'm trying to address here from a central office perspective. Cool. Any other question? Nope. Thank you very much.